When graphing these reciprocal functions, this function family, we look at this equation as y equals a over x minus h plus k. Now that is the parent function and how it would be transformed, and we've learned in the past little things that we know that, well, a stretches and compresses, and it also reflects. Those are the values of A. H, we know, moves it from left to right, translates it, and then K will move it up or translate it up and down. So as I look at these, let's just use that and some things that I need to know that my asymptotes. My vertical asymptote is going to be x equals h, and then my horizontal asymptote is going to be y equals k, and those are going to be asymptotes. Again, your function gets very close to it but never touches. So as I take this first example, let's just go and put it into its translated form. It says y equals 12 over x minus plus k. Now x minus, there's nothing there, so that would be minus 0. And then there's no k there, so that would be plus 0. And identify some of these key features. Well, if I graph it real quick. Okay, so here, go ahead and graph this real quick. I can just throw in some points here. I do know that my asymptotes, my vertical asymptote is x equals h, and h here in this equation is going to be 0, and my horizontal asymptote is going to be y equals k, which is 0. So I know that technically there is an asymptote here on those axes, that the function is never going to touch. And then so that means there's no x-intercept, no y-intercept. And if I were to just simply plug in a few numbers for x, say if I plug in 1, I get y is 12. When I plug in 2, I get y is 6. When I plug in 3, I get y is 4. And let's do the opposites of that. Or let's graph it and see what happens. When x is 1, y is 12. When x is 2, y is 6. When x is 3, y is 4. When x is 4, we know that y is going to be 3. So we know that this is going to do that. And then when x is negative 2, y is going to be negative 6. So negative 2, negative 6. And of course, we can repeat those because we know there's going to be a few. Negative 3, 4. Or sorry, negative 3, negative 4. And then negative 4, negative 3. So there you go, as my asymptotes are along the axis. So that's how I'd graph that. I've seen some of the key values there. So for each of these graphs of y, compare what are the effects on these graphs. Well, do I need to compare them? I have y equals 1 over x minus h plus k. And they're asking me what are the effects of the graph when a equals 1/2, when a equals 2, and when a equals negative 1/2. Okay, so again, in when a is in between 0 and 1, it compresses. When a is greater than 1, it stretches, and then when a is less than 1, or when a is negative, it is also going to reflect over the axis. So in this case, we know in our equation that a is currently equal to 1. Well, what happens if I change in a when a is equal to 1/2? Well, 1/2 falls right here in between 1 and 0 so that I am compressing. So that will compress the function by a factor, and hopefully you know that that factor is going to be 1/2. And then b, if we have a is equal to 2, well, that is greater than 1, so we know that we have a stretch. So we have a stretch. So we have a stretch by a factor of 2. And then c, negative a is equal to negative 1/2. Well, it is going to compress it. That still happens. Compressed by a factor of 1/2 and reflected, because we have a negative, reflected. There you go. So those are the effects that we have just by understanding those values that we've repeated over and over with the different functions. Okay, so graphing a translation. So again, y is going to be equal to a over x minus h plus k. So in this equation, we know that k is equal to 6, and we know that h is going to be equal to 4, right? H is 4, and then k is 6, which is going to be easy for us to graph, because when we graph these, the first thing we want to do is draw in my asymptotes, and I do it by using a dash line. So if h is 4, that means I have been shifted right 4, so I no longer fall on the origin. I am moved right by a value of 2. So again, x is equal to 4 is going to be my vertical asymptote, and then k is 6. So I am looking at this imaginary line that the function will never touch, and that is going to be y is equal to 6. So there you go. Those are my two asymptotes. Y is equal to 6 is my horizontal asymptote, and then x is equal to 4 is going to be my vertical asymptote. A is the value of 1 here, so it hasn't been stretched or compressed, so I could just plug in some numbers and get some numbers out of it. But I do know, let's just identify this real quick, up 6 units. And then, of course, this one is going to be right 4 units. Gosh, right here, I'm happy if we're looking at my function, it's going to, when it can equal 4, it's going to look something like this. And then something like this. And that might get us what we need. So very brief sketch. Call that a sketch. And then what is the domain and the range? Well, it cannot, my domain, it cannot be the value of x equals 4. So it would be from negative infinity to 4, and then from 4 to positive infinity, of course using parentheses because neither one of them are included. And then for my range, I'm going to have from negative infinity to 6, because we're never going to touch 6, and then from 6 to positive infinity, because it goes on forever up and down, left and right, except for its asymptotes. Let's see here, write an equation for this transformation. Well, if my parent function is going to be 2 over x minus and then plus, it looks like my function has been shifted over the value of 1. So it looks like h is going to be 1. and then it has been shifted down to 4, so it's going to be -4, or let's just go ahead and -4. So there's the equation for that parent function right there, and it has been translated right 1, down 4.